In this video, we will discuss the concept of safety parabola, and we'll also find the equation of the parabola. So let us look at the concept of this. Suppose you project a particle, let us say from origin with a speed u, but at different angles of projection. So remember that the speed of projection is same, but the angles of projection are varying. It is variable. You can project it at any angle. So all the possible trajectories, you can see these green colored parabolic trajectories, all the possible trajectories of the particle will lie inside an envelope, and this envelope itself will be a parabola. It will lie inside an envelope. You can see this yellow colored envelope over here, and this envelope itself is a parabola, which is called as a safety parabola. So for a given speed u, all the possible trajectories of a particle will be enclosed inside this yellow colored parabola called as safety parabola. Now, how do we find the equation for this safety parabola? Suppose you project the particle vertically upwards with a speed u. You project it vertically upward. Gravity is acting downward. So if you project it vertically upward with a speed u, the particle will reach a maximum height of u square by 2g. So this point A is lying on this safety parabola, and we can write the coordinates of point A as x coordinate as 0 and y coordinate is the maximum height reached by this particle, which is u square by 2g. Similarly, you can obtain a maximum horizontal range of the particle, which is u square by g. So the extreme end, this point B, which is lying on the x-axis, I can say that the coordinate of point B is u square by g comma 0. Point B is the farthest distance up to which I can project a particle. So this origin to point B, this distance OB is actually the maximum range of the particle when projected with a speed u, which is u square by g. Similarly, on the negative x-axis also, I can say that if you project at 45° with a speed u, you will obtain a maximum range of u square by g. So I can write the coordinate of point C as minus u square by g comma 0. Now all these 3 points, A point, B point and C point, should lie on this safety parabola. So we'll use these 3 points to find the equation of this. Let us assume that the equation of safety parabola is y equal to ax square plus bx plus c. So we need to find the values of these constants a, b and c. Now for point A, whose coordinate was 0 comma u square by 2g, this coordinate I am putting in this equation. So y is u square by 2g and the value of x is 0. So we'll directly get the value of constant c, which is u square by 2g. Now, if you put the coordinates b and c in this equation, for b, which is u square by g comma 0, the value of y is 0 and I have replaced the x coordinate as u square by g. Similarly, for point C, you can replace the x coordinates as minus u square by g and the y coordinate to be 0. So you have 3 equations. The value of C is already known, and you can find the value of A and B. Simply, you can add the second and the third equation and you will directly end up getting the value of A. And if you know the value of A, then the value of B can also be found because the value of C is also known. So I'm not solving these equations. It is pretty simple to solve these equations. You will end up getting A to be minus G by 2u square. The value of B will come out to be 0 and the value of C is u square by 2g. Sorry, this is u square by 2g, right? So this is also 2. So the final equation of safety parabola, what is the equation? Value of A is minus g by 2u square. So minus of g by 2u square into x square. The value of B is 0 and the value of C is u square by 2g. So this equation represents the equation of safety parabola. Now let us look at some important points which you can use in your numericals, which is concerned with the safety parabola. Suppose you have 3 points. Let us consider a point P which is lying inside the safety parabola. Consider a point Q which is lying on this safety parabola and a point R which is outside, right? So you can see that it is not possible to hit point R. There is no trajectory which is passing through point R for a given speed U. So if a point lies outside the safety parabola, it can never be hit by a particle. So you need to change the speed of the particle in that case. But if a particle lies inside the safety parabola or on the safety parabola, then definitely we can hit hit that particular point, there will be a trajectory passing through that point. Now, again, if a point lies inside the safety parabola, like you can see here, point P, there are two possible trajectories which will pass through this point P. So any point which is lying inside the safety parabola, there are two possible trajectories which will pass through this point. But if a point lies on the safety parabola like this point Q, there will be only one possible trajectory which will pass through this point. So these are few points which you can, which will be helpful in certain numericals, that if a point is outside the safety parabola, it can never be hit. If a point lies inside the safety parabola, there will be two possible trajectories which will pass through that point. And for a point on the safety parabola, there is only one possible trajectory, right? So based on this concept, you can give a try to a particular question. So this is try yourself question. Suppose we project a particle with a speed, let us say this speed is under root of 380 meter per second. So I'm projecting a particle with a speed of root 380 meter per second, and the angle of projection is varying. You can choose the angle of projection according to you. So the speed remains fixed under root of 380 meter per second. Now we have a point P whose coordinate is 6,8 meters. This is an SI unit, and gravity is acting vertically downward. So we need to show that for this particular speed u, there are two possible trajectories which will pass through this point. And since there will be two trajectories, the time taken by this particle to reach point P through those two trajectories will be different. So we also need to find the time difference between the two paths which will be taken by the particle to reach point P. So give this question a try and we'll pick up the solution or take up the solution in next video.